Les damos la bienvenida a la 18ª edición de la IEEEXtreme y la número 15 organizada por IEEE. Para los que no nos conocen, somos Liam, Miranda, Luana y Facundo de la comisión directiva de IEEE. Y bueno, estamos muy contentos de tenerlos todos acá con nosotros y estoy seguro de que esta va a ser la mejor edición de la IEEEXtreme que jamás se haya organizado en IEEE. Vamos. Estamos muy contentos de este año poder compartir una gran noticia, y es que alcanzamos un récord histórico de inscritos con 28 equipos y 81 competidores. Y bueno, también sumamos este ciclo de charlas como bienvenida del evento para que todos lo puedan disfrutar. Y bueno, antes de comenzar con las charlas, queremos hacer un agradecimiento especial a todas las personas que hicieron posible que ocurra este evento hoy en día. En primer lugar, a todo el equipo de voluntarios de IEEE. Somos más de 50 personas que trabajamos durísimo durante varios meses para que esto pueda existir. Y un aplauso, por favor, para todos los voluntarios. Y sepan que somos hoy presentes 42 voluntarios para asegurarnos de que todo suceda como corresponde, así que cualquier problema, cualquier duda que tengan, pueden acercarse a las personas con la credencial de staff o organizadores y les vamos a tratar de dar una mano como mejor podamos.
También es necesario agradecer a los sponsors que hoy nos acompañan y gracias a ellos es posible tener este evento y tenerlos a todos ustedes acá presentes. Entre ellos está Yokogawa, Terre, Innovit, Katpaki, Igewaon, no me quiero olvidar a nadie. Así que muchas gracias a ellos debemos de un aplauso a los sponsors principales. Y me toca también mencionar a dos personas clave y muy especiales para nosotros, que también este evento no hubiera sido posible sin ellos, sin su ayuda. Nos gustaría reconocer su gran aporte, los vamos a nombrar, así que cuando lo hagamos les pedimos que se acerquen. Una de ellas es una persona que nos acompaña a la rama en general desde el comienzo de la organización, es quien bueno, nos permite hacer todas las compras del evento y también es una gran persona que nos acompaña, nuestro rector el día de hoy, Miguel Aguirre.
Bueno, bueno, IEEE es la sociedad profesional más grande del mundo, tiene más de 450.000 miembros en 160 países. Es el Instituto de Ingenieros en Electricidad y Electrónica y es la puerta a todo lo que es tecnología hoy en día. Para que tengan una idea, Wi-Fi y Bluetooth no existirían si no fuera por IEEE, porque todos nos podemos conectar a Wi-Fi, porque IEEE estudió y sacó el estándar en el cual todos nos comunicamos de la misma forma en cualquier parte del mundo. Y como eso hay miles y miles de estándares que utilizamos en nuestra vida en todo lo que tenga que ver con tecnología. Y además es una excelente forma de acercarse a la gente que necesitamos, que sabe más que nosotros, y siempre está abierta sobre todo para los miembros de las ramas estudiantiles, ¿sí? Si ustedes le mandan un mail a cualquier IEEE en el mundo diciéndole, hola, soy miembro de la rama estudiantil de Argentina, me interesa tu trabajo, ¿me podés ayudar en algo? 99% de probabilidad de que le digan sí, si no me avisan. Bien, empezamos con la rama hace muchos años ya. Todos los años van cambiando las autoridades, van cambiando los que trabajan, y todos los años, la verdad que me asombran de lo bien que vienen trabajando. Así que muchas gracias a todos los voluntarios. IEEE es voluntario, así que muchas gracias a todos.
Bueno, y en segundo lugar, pero no menos importante, a esta persona podemos decir nuestro superhéroe, porque la verdad es que nos ha salvado en más de una ocasión, siempre también apoyándonos. eres Cerezo y Villaverde, y nuestra
No, gracias, no me lo esperaba, no me lo dijeron, porque si no, no sé si venía. La verdad que nada, yo estoy en la Secretaría Académica, muchos me conocen, y estoy en contacto con todas las actividades de los chicos, y siempre rescato lo mismo, que digo que esto es puro voluntario, como dijo Miguel, es todo de ellos, nosotros tratamos de facilitarle, aunque a veces pareciera que no, pero tratamos de facilitarle los espacios, los lugares, y bueno, mi rol es un poco interactuar con todas las áreas de la universidad para que se lleve a cabo. Y la verdad que verlo después de tantas reuniones, tantos meets y tantas charlas que tuvimos, la verdad que es una alegría enorme. Espero que lo disfruten, ellos laburaron muchísimo para que esto sea un éxito, y lo va a ser. Y nada, aprovechenlo, disfrútenlo y los felicito a todos los voluntarios. Y muchas gracias.
Bueno, y ahora sí, sin más preámbulo, vamos a arrancar con lo que para muchos de ustedes vinieron hoy el día lindo. Vamos a arrancar con el ciclo de charlas. La primera de las charlas va a ser en inglés y después vamos a volver al castellano. So for the first one, we'd like to welcome please Ahmed Bashir from DevRap.
Who's excited to be here? So I must apologize. This is a talk in English. I apologize. I do speak a little bit of Spanish, but not nearly enough to pull this off. So if you can, bear with me, and hopefully I'm speaking at a pace and using words that everybody can sort of understand and appreciate. But very excited to be here. We're gonna get this ball rolling. So I'll tell you what. We are representing DevRev. DevRev is a company that is looking to reshape the future of work using two technologies. One is AI, and the other is design. We're going to talk a little bit about that. And prior to DevRev, I did spend nearly 13 years working at Apple. I was part of the founding team that introduced iCloud. Many of you, raise your hand if you know about iCloud. Okay, okay. And then also iMessage, raise your hand if you know about iMessage. Maybe a few here. Okay, okay. Some of you guys? Okay, outstanding. So a lot of interesting things have happened over the last 15, 18 years, but not as exciting as what we're going to talk about today. And I hope you guys enjoy it. Now, obviously, many of us here are going to take part in hackathons. Some of the people I was speaking to before we came over here were saying, Ahmed, have you taken part in hackathons? And I said, well, look, I've been at DevRev for the past 3 years leading engineering, and we do hackathons at DevRev. And we're going to see a few pictures here and there while we have this conversation together. And this is really a conversation. So I need you guys to be engaged with me. So who's with me right now? Okay, very good, very good. This is a picture I took. This was the first rally or hackathon that we did. This was from Alston. So you can see that people, they didn't leave anything. Windows, whiteboards, everything was covered. We were doing design, we were doing reviews. It was exciting. And I hope it's as exciting for you guys. Maybe the first of many, maybe you've done this before, but hackathons, it's a lifeblood of how people really learn to build things beyond themselves, beyond the projects in school, to get out there and meet people, build community. And I'm incredibly proud of everybody here who's taking the time to participate. Good for you guys. I'll just give you guys a quick applause. And I think I captured most of what Facundo and others were saying. It sounds like this hackathon, you got what, 81 people participating? Yeah, 81, yeah. Okay. And so you got 81, but you got people all over. Facundo, how many different sites? More than 10. But like in the world. Oh, and actually, yeah, like everywhere in the world. First like Florida. More than yeah. Wow. Okay, so over 50 countries. Let me tell you guys. Look, we were taking pictures earlier today. I kid you not. There's people that are participating. That you got to keep your A game right now because there's people participating everywhere. And people were sharing pictures with me. I just want to show you. There's people getting ready for this thing. I got a picture. I just wanted to share it with you guys. No, seriously. I'm kidding. So folks. This is an AI generated. I don't want to get sued for anything. This is an AI generated image. But for anybody who's used Midjourney, anybody here who's used Midjourney? Okay, so we got a few people. This is a picture that it has been completely generated by AI. It took me no more than maybe 7 or 8 words to describe this image, and this is what I got. It took me one try, and this is how unbelievable AI is. It's so unbelievable. It's so unbelievable that it is considered to be one of the most interesting and most important technologies we've ever seen in civilization. So you heard of GPT, but there's another GPT, and that is a general purpose technology. Okay, raise your hand if you're able to keep up with the pace at which I'm speaking. I just want to make sure. Okay, very good. Thank you so much. I want to be mindful. So general purpose technologies. This is something that was published several years ago. There was a seminal paper, a book in fact, by three leading authors in industry who actually went and captured what they believed were the 23 most important technologies in all of civilization, starting with our ability to domesticate plants. And from there, it got into domesticating animals, being able to create a wheel, being able to create factories, steam engine, industrial revolution, airplanes, computers, internet, and that last one, that's the one that we are now contending with, the one that's going to be the rocket ship that takes us forward. And it's the one that I think we are all excited about, right? And that is artificial intelligence. So let's talk about artificial intelligence. Like I said, it's one of the central pillars of why we believe as a company that we're going to be able to succeed and change the way work is done. And I think you guys should all be excited about it as well. Let's talk about it. So far, so good?
Yes.
Okay, so where do we want to go from here? What I'll tell you is this. Obviously, all of you guys are expert coders, is what I've been told. So can anybody explain to you what this program does? It's a very simple program. Tiago, what does it do? No, I don't read it. Yeah,
It seems that it's printing.
I think it is printing.
Assembly, of course, so I can't.
So yeah, 100%. You know what? A for effort on that one. It's also, I think the contrast is not very high, but exactly right. It is x86 assembly language that's using Linux system calls, and it is actually dealing with memories and registers. But at the end of the day, this program is actually counting to 10 and printing. So it's going to count and print to 10. This is what it looked like, folks. Imagine how many developers we would have in the world if this is how you had to print 1 to 10. Just imagine that. So this was the reality in the world not too long ago, right? Now what do we do? Well, let's look at what maybe a more modern language. Can anybody recognize what language this might be? Okay, look at that. Right in the front row. So this is absolutely C, and this is counting and printing 1 to 10. Fantastic. But we got further than that even. And what you have to understand is when we were working with assembly language, was it burning fewer CPUs or was it burning more CPUs than C?
I think more.
It was actually burning way less because it was dealing with jump statements and dealing with register directly. So it was actually incredibly efficient. And going to C from assembly language was incredibly expensive. Incredibly expensive. So why did we do it? We did it because it allowed us to have a tremendous surge in the number of developers because the developers were able to use these new abstractions. They were able to build communities. They were able to learn from each other and see the documentation. Right? We didn't have all that assembly. So this was a huge boom to the population of developers and the ease of development. You didn't have to deal with, well, you did still have to deal with memory allocation, but it was way easier, for example. And let me show you the next language here. What is this? I think everybody knows what this is. For every I in a range to 10, print I. I think many people would find this to be the most convenient way to understand what the code does. Am I right? Yeah. So this is which language? Python, exactly. So now what we've seen is Python, which is probably way more expensive to operate, right, than a C would be. And C is way more complicated or more complex and more compute intensive than an assembly language. But we did it anyway. And now, thanks to all of these abstractions, all the work that's been done, we now have anywhere from 30 to 40 million developers in this world. 30 to 40 million developers. But how do we get to 100 million folks? Because the future of work, if you really want to reshape the future of work, what are we betting? We're betting as a company, we're betting there's going to be 100, maybe 200 million developers in the next 15 years. Generationally, we might see the biggest jump we've ever seen. Now, how is that possible? Well, I'll tell you how it's possible. And actually, many of you already know the answer, right? What's going to happen is this. So I wrote define maximum and the rest is right there. What do I have to type or what do I have to click on the keyboard to make it happen? There you are. You already know. You just press tab and it's there, but it gets better. I'm gonna actually go here and say, I actually don't know what this thing does. What does it do? I'm literally gonna say this. What does this code do? And it tells me in plain English what it does. Isn't that nice? Okay, so if I want to know how to write maximum, at first I figure out what minimum is doing, then I say define maximum, and then I press tab and it works. But I can do better than that. What if I don't even want to say def maximum? I just want to say, give me a code that does this. Write a function that given a list frequency table. And it's that easy. Raise your hand if you use technology that does things like this. We got a lot of people. Okay, don't be shy. This is not. I'm not a professor. I'm not gonna downgrade you because you're using AI. I'm gonna uplift you by using AI. AI is exactly what you should be doing. Okay, that's the only way we're gonna get forward. This is the future of programming. Imagine how many people can code if this is how easy it is. And remember, we're using what Cloud 3.5 in these examples. Is what it showed. Imagine what 4.5, 7.5, 9.5. Just think about that. We'll talk about the generational advances in LLM. But this is incredibly exciting, folks. Just show of hands, 15 months ago, how many people were using Cursor or Copilot? A couple of people. Okay. And raise your hand if you've used it in the last week, 2 weeks. Okay. You see what's happening here. You see the transformation in front of you. This is incredibly exciting stuff. This is how the future of work is reshaped. Okay. So we're going to get to 100 million, maybe more developers around the world, and we're going to create a tremendous population of communities that are going to make it easier and easier. And they're going to be willing to pay for these abstractions and these conveniences. So it's truly an exciting moment in time. But how do we get there and what does it take? Let's talk about it. Before we talk about it, here's another picture of a rally that we did. You can see people on their computers, what it looks like. Let's get to what's next. So I told you the exciting part of AI, but also I don't know if I mentioned this, but we are actually DevRep is a sort of a international company. So I'm here visiting. I'm usually in the Palo Alto, California office. We've got an office here in Argentina. I tried to be a little smart, and I asked our friends at Midjourney to draw a little map and point out the Buenos Aires office. And this is what it did. That's not what Buenos Aires is. I don't think it got it right. And you know what? With a little bit of help, maybe it could have gone there. But what does this mean? Does this mean that AI is forever going to be useless in a professional setting? What does this mean? And how do we get further from here? But I'll tell you this. This is an exciting moment because we understand a little bit about how it works and when it doesn't work, why it doesn't work. And so what we have to do is really double down and understand how do you decorate and how do you build layers, right? Because you need layers. If you think about TCP/IP, which is how we do modern networking. This is how the cloud was designed around TCP/IP. This is how mobile computing was designed through protocols that use TCP/IP, right? How did this work? Well, we had to build a physical layer, but then we had a transport layer, right? We had an application layer, and every layer was distinct in what value it created, so that together all the layers were able to give us the experience that we needed. So perhaps just trying to see what works and doesn't work for LLM is just a myopic way of looking at it. Maybe what we have to do is figure out what layers do we need to be able to create the value that we need to create. So let's talk about that a little. So first thing I'll tell you is you have to understand that these systems, while we're on the topic of LLMs, these LLMs are designed through a painstaking process of discovering data so that you can use that data as a data set to train these things. Then you have to spend a tremendous amount of time and compute to actually do the training. And you can actually use a certain amount of content, a certain data set, and train it for a certain amount of time and use a certain amount of compute. And the same data set can lead to better and better results if you train it for longer and longer. That's been proven. So you can actually manipulate the data set. You can have a larger data set, but you can also have the same data set and you can have just longer and longer, more sophisticated training. There's more. You can also control the model size. You can have much larger and larger models and actually get better and better results. But at some point, people aren't going to just keep moving things around and saying, okay, what do we want to do? Try all the different parameters because this is an endless game. What we're finding now is that people want to have a certain size model, and they want that size model to actually serve specific use case, and they want to train it longer or perhaps bring more data. So how much data can we have? So some of the most sophisticated models that we see today, does anybody know how many tokens they've been trained on? Any guesses? 100 billion. So there are some definitely 100 billion. What I understand is that there's some that are even up to 15 trillion. Is what the most advanced models in the world are looking at right now. And by the way, right now we understand that Anthropic builds models. We understand that Llama is a model from Meta, and there's other models. People know some other models. Some models coming out of OpenAI, many other systems, right? And in the future, we might even see countries and nations build models, right? Because they have so much data. The question is, where is that data coming from? If you think about the entire English language corpus, see what's happening here is that we're actually taking this data and we're putting it into the system to be able to train it and create these incredibly important models. But where do you get the data and how much data is there? So if you're already training with 50 trillion words, how many words are there in the English language that are available for public training? Well, by some estimates, maybe 40,000. If you start to take private content, you start to take private content from Gmail and Facebook and Instagram. You start to take private content from Reddit. And you start to build that. Maybe you get to 100 trillion, 200 trillion. You start to take every language in the world. You start to take all the videos in the world. Where do you get to? Maybe you get to 1,000 trillion. Maybe you get to 2,000 trillion. These are the best estimates you'll find in the world. Where does it end? We don't know. And that's what makes this so incredibly exciting. So we might find that there are models that are created with 100x the data that we have today. And that means they may take 100x more money to build. Can you imagine a model? You are already living in a world today that's using what most people would describe as a Gen 2 model, where ChatGPT 3 you can think of. GPT 3 may have been the first time you heard about GPT or heard about large language model. Raise your hand if that was the first GPT or the first large language model you heard about. Well, that was what people call a Gen 1. Today's models, the ones that you use when you use cursor and so on, that's a Gen 2 model. Now imagine, what is a Gen 3 model? What's a Gen 4 model? And people generally describe each of these successive generational models to require an order of magnitude more money to build. Can you imagine a Gen 4 model? It'll have been a model that was built off of 100x the cost. That means way more training was done, way more data was brought in, way more cross training was done, and the understanding of what kind of training is beneficial will have advanced significantly. So there's a lot of opportunity here. So we're going to be in this race, a space race, or whatever you want to call it, where we're going to be trying to grab as much data in the free world as possible and trying to create the absolute most magical large language models. But it's not just about that, because no matter what you do, you understand, just like when I showed you that image where we had Buenos Aires in the middle of the ocean, you have to understand that these systems will not be perfect. So how do you build on top of that and create the right experience? Well, there's a lot to do. First thing that we've done, and I think that you're seeing this more and more in the industry today, is that we really use knowledge graphs. And these knowledge graphs are going to be incredibly important. Because what they do is they start to use large language models in the capacity that they're most effective. And what they do is they take information, what you could call facts, and they start to transition these facts from data in all capacities, whether it's numerical, whether it's data in the form of a structure, or it's in the natural language format. They take this information and they turn it into vectors, and they start to store it in these vector databases. And we are no different as a company. We've been working on our vector databases for 3.5 years, more than that. And so these incredibly important knowledge graphs are going to be built through deep integration with all your systems, right? Whether you're in the academic domain or if you're in the professional domain, there's going to be a tremendous amount of information that's going to be brought in from many different systems. They're also built natively inside the system that you use to primarily drive your work. This information is going to sit in systems like this that are going to basically take numerical vectors and understand deeply how to take those vectors and relate them to questions that you're asking or automations that you're transcribing. This is the future of work, folks. And it goes further than that. What's going to happen is we're going to find that all the information that you're accessing is going to require deeper and deeper personalization, customization. Because the way I want things answered may not be the same as Tiago or Facundo or Juani. It's not going to be the same. So you cannot create the same vector database result. You're going to need multi-tenants. You're going to need skill for that. You're going to have to understand a lot. You're going to have to re-rank. You're going to have to reprioritize. There's a lot of layers to this cake that are going to be researched and advanced over the next 5 to 10 years. Very, very exciting. But we're going to live in a world where these numbers, this floating point arithmetic, this matrix multiplication that we took for granted in linear algebra is going to basically reimagine the entire world. And what we need for the future of work to succeed is a platform that really embraces this. And that's what we're looking. Any questions so far? Okay. Yeah. Interesting stuff so far?
Yeah.
Okay, fantastic. So where do we go from here? Well, um, when you have this mechanism, the next thing you have to do, so we talked about the large language model, then we talked about the vector data, the system, the knowledge graph. But knowledge is not everything. You have to be able to drive knowledge to take action. And these actions are going to require an orchestration system, a workflow engine, if you will, an engine. And this engine is different from every engine that's preceded it. Why? Because the automations that we've built using technology thus far has always driven policies, heuristics, and well understood state machine transition. Why? Because we have always understood computers and machinery to be deterministic, right? You've heard this. Deterministic state machines. This is what they are. However, what we've done now with large language models and all the derivative technology that's coming out of it, we have created a frontal cortex, a prefrontal cortex. We have basically created a sense-making mechanism, a judgment mechanism, and it works really well. It's only getting better. So now when you put that judgment construct on top of the ability to run anything deterministic, it is able to take the judgment that humans brought and actually apply it in a computing environment. That's what makes it incredible. So what you do is you build a workflow engine that is able to embrace the ability of large language models to build what we call agent skills. This is an incredibly important advancement that we're going to take advantage of in the future of work. This future of work is going to be able to make judgment calls like we did, sometimes at a scale that we never had. What else you can do with this workflow engine is actually create these agents. And these agents are able to take skills that are disconnected but well defined, and actually understand how and when to use which skill. So that if you said, hey, if this customer is not happy with this product, I'd like to reach out to them and get their feedback and let me know if I need to take immediate action. You can ask that question, and that will be broken down into a series of steps, some of which require judgment, right? Some of them require patience. These are not the types of words we've ever associated with computing. But here we are thinking about them as an automation that could actually save us tremendous amount of time in the future. So it's very important. So this is what's going to happen. So what are the steps that we need to take? Well, first thing we need to do is start to understand how to define skill. So if there's a specific skill, can we code it? Can we codify that skill? Can we define that skill? But not just one skill. What we need to do is actually codify a series of skills. We need to take all of these skills and be able to define them in code. And we have to be able to understand how to translate and to articulate to a computer, to an orchestration engine, when we would like and when we actually use which skill. And if we're able to do that, we're able to define the skill, many skills, and we're able to explain how and when we use our judgment to apply these skills. Then these systems will be able to learn, adapt, and apply. And it's going to save us a tremendous amount of time. So far, so good? Okay? So skills, we've never thought about skills this way. We thought we were skilled. Now it's time for us to create skilled artisans. And these skilled artisans are actually machines. Incredible. What's next? Well, we talked about hackathons. Here's another hackathon image. This one's not from Austin. This one's from Chennai, India. We have them all over the place. Where do we want to go from here? We've talked about agents, we talked about skills, we talked about large language models. Well, we'll show you Scott Belsky. Scott Belsky was at our conference earlier this year when we had our conference in New York. And this is a quote from Scott Belsky, which is actually a 2023 quote. He says this, AI will collapse the talent stack. What does that mean? What does that mean to all of us developers? What it means is the same thing it means in technology, in software SaaS products that professionals and businesses have been using for the last 30 years. The nuances, the subtle differences between the product that we've been using to run our sales CRM, to run our customer support, to run our product development, the nuances, the subtle differences between these products will become irrelevant. Okay? What does it mean to the human? Because many of you probably are not in the work domain yet. What does it mean? It means the same exact thing. That means that if I can just say write a function that creates a frequency table, if I can say that, then what's the difference between a developer of today, in today's definition, and a product manager? What's the difference between a project manager and a developer? What is the difference? If everybody can write in English language or any language, and they can interact with an IDE and build code, what's the difference? I'll leave that to you as a rhetorical question. But the comment remains that AI will collapse the talent stack. And what that means is people who bring general creativity are going to be able to have tools at their disposal that they've never had. There may have been a person somewhere in the world that had tremendous creativity, but they did not have the skill of writing code in the traditional sense. That person, their world is opened up. Agree or disagree? Right? Okay, so that's what's happening. We're collapsing the talent stack. This is incredibly important. But what else? We want more. What if we could collapse time? So I work with team members in India. I've got some coworkers here who also do the same. There's a 12.5 hour time difference between India and where I live in California. So at 8 o'clock, it's already 8:30 for them. Think about that. So do I have any, sort of in the traditional sense, do I have any overlap in terms of workday? Zero. I have no workday hours. But what if I could actually go from 0 to 4, 4 to 8, 8 to 10, thanks to these automations, these skills? If these skills were available, so Ahmed, as a series of skills, was available to people in India or Argentina after office hours, could that be useful? So in a sense, you're theoretically collapsing the time, which is incredible. Think about that. This is how you build global teams. This is how you succeed. This is the future of workflow. This is what I mean. What else can you do? 10 minutes. Holy cow. I'm gonna go fast. I think you already know what this means. We're gonna collapse a lot. We're gonna collapse language barriers. We're gonna collapse gender barriers. We're gonna collapse a lot. Because if we can be seen and be appreciated for our work as the skills that we are able to animate, as we are able to leverage ourselves at machine scale rather than human scale, it starts to break down all sorts of barriers. Truly an inspiring and I think a very positive future that I see. So I'll leave it there. I'm gonna go way faster because I got the 10-minute warning. But I will just say is this deep work. If people are like, what am I gonna do if this thing's doing so much? Well, first of all, you're gonna bring your creativity and you're gonna start to do the deepest work you've ever done. If the clustering, the prioritization, if the sort of grunt work that we've had to do, the preparation we have to do, if you have an assistant, all of you have the assistant, multiple assistants that are able to help prepare you to have the context that you need. What type of deep work could you do? That's the question that all of us should be asking ourselves. That's the future of work. It's deep work that allows us to answer deep questions and have that sense of deep satisfaction with what we do professionally. It's an incredible opportunity. I leave you with that question. Okay. I'll tell you a few other things because here's another hackathon picture as we kind of shift gears. I'll go a little faster here, folks, if you don't mind. I apologize. There's a lot that we have to do outside of AI. People talk about AI. I talk about AI. That's what we've been talking about. But there's a lot of pieces to this puzzle, my friends. Communication continues to matter a lot. At DevRev and many other companies, we continue to put a lot of time and effort into WebSockets, webhooks, APIs. The way we connect, the way we communicate is going to change a lot. Microservice architectures are going to change when every system is dependent on a skill agent. And that skill service is now going to really start to consolidate things. So architectures, microservice architectures are going to change. Think about that. How communication happens is going to change. Change capture is going to become important. Being able to listen to actions, react to actions, track events, very, very important. What else is important? Integrations, being able to understand structured data, unstructured data, being able to synchronize content from different services so that you have all the right information in your knowledge graph to take action exactly when you need to take action. Understand recipes so you can make sense of data from different systems because they don't always match, right? This is all going to be incredibly important. What else? We have data modeling, customization, templates, very, very important information. We work on all of this in our company. Sessions, being able to see real time what's happening. Can you imagine shipping code? Who's heard of continuous deployment or continuous integration? Many of you have heard of it. It's the idea that your software goes to production almost continuous. Well, if you think that's continuous deployment in the future, if you're able to in real time study the habits and actions of your users, by looking at the sessions and being able to simultaneously, through machines, make sense of what they're doing and what they're not doing. Can you imagine the rate at which features are going to be prototyped and deployed? Just imagine that. This is going to be a future with rapid prototyping, with rapid impressions, and an understanding of feature and user like we've never seen before. Troubleshooting will never be the same. Rapid iteration will never be the same. It's going to be an incredible moment when we have the ability and the wherewithal of machines to help us with it. Obviously, analytics is going to change quite a bit. At Deborah, we believe that in the future it's local. The future of analytics is not a data lake in the cloud, in the cloud, but it's actually the ability to do local in-process analytics on your browser, on your desktop. Visualizations are going to be more beautiful than ever. You're going to have not just the dashboard that you're used to, you'll have a conversational insights partner where you can ask questions and get information back whenever you need it. It's going to answer all the questions you have. All your most important questions will be answered conversation. It's a truly remarkable future we're looking at here. And then, of course, I'll end you with the developer profiles. How are we going to have developer profiles when some developers are humans and some developer profiles are non-human? This is a future that I'm going to leave you with: access controls, dynamic roles, and portability. Would you love to work at a company where once you have left one company, you can take your agent profile, your AI profile, and take it to the next company so that your AI, who is helping you do 80 or 90% of your work, you can continue to use that AI in the new world. That's the future of work. Being able to not just move yourself, but also move your AI companion, your teammate with you. That's the future that we foresee at DevRev, and we're very excited about it. I think that's about it. Do I have 5 minutes? Yeah. 5 minutes. Okay. Let's talk a little more. Are we okay? Yeah. Okay, sounds good. So let's just talk a little bit real quick. So who are we? The diverse team, DevRev. We got people all over the world, smiling folks. You can see those pictures. We got a lot of folks. We got a lot of folks here in Argentina as well. We don't always talk about AI and technology and webhooks. We sometimes go fishing. We do. Sometimes we go into the jungle. Sometimes we hang out with the tigers. This is a picture that I took with a few of our friends in the India office. We also sometimes see, anybody know what animal that is? Leopard. That's a leopard, folks. I went to South Africa. I did not see a leopard. And then I went to India and saw one. I'm very excited. And it was all thanks to Deborah. Thank you, Deborah. Okay. What else? We're not always looking at animals either. Sometimes we look at ourselves. But that's a picture I took in a city that we all traveled to. A couple of companions. These are people that are coming from many different sites, and we all kind of hung out together as one big family in a city that we had never visited before. So a lot of interesting things happening at Deborah. I'm here. This is my second visit in Buenos Aires. The second visit, I didn't think I was gonna have a second visit, but thanks to Deborah, I did. So thank you, Deborah, one more time. And I would just say, oh yeah, by the way, we did raise $100 million and became a unicorn relatively recently, so that happened too. So if anybody's interested in Deborah, anybody wants to know more about it, happy to tell you more about it. I appreciate your time. Hopefully this was not a waste of time for you guys, and good luck with your hackathon project.
Hola, hola. Antes de pasar, chicos, antes de pasar con la siguiente charla, les recordamos que después de que termine Gustavo con su charla, va a haber un espacio para preguntas y respuestas, tanto con Gustavo como con Ahmed, así que si se quedan con cualquier duda, sepan que hay un espacio para preguntas después. Ahora sí, bienvenido Gustavo Cerezo.
Bueno, Ahmed ha dejado la vara muy alta, así que va a ser su charla. Felicitaciones. ¿Quiénes de acá son del área de IT o estudiantes profesionales de IT? Y electrónicos, procesos y otras cuestiones. Más cerca. Bueno, mi intención hoy es poderles dar una perspectiva de lo que es el OT. ¿Quién ha escuchado hablar de qué es lo que es el OT? Las tecnologías de la operación es algo que está relacionado con la industria, ahora lo vamos a ver más. Bueno, aquí me imagino que todos conoces, es Information Technology, tecnología de la información. La OT es todo lo que está relacionado con desde los sistemas de control, sistemas de automatismo, sistemas de seguridad, también todos los instrumentos que van a encontrar en la base de lo que es el OT. La detección, temperatura, nivel, caudal, todos los que vengan del proceso van a identificar todas estas variables que son fundamentales para poder controlar un proceso, para asegurarlo. Bueno, van conectados a un PLC, un DCS, un RTU, un controlador, que es aquel que puede controlar y asegurar ese proceso a través de la lectura que hace de material. Todos estos equipos hoy cada vez son más inteligentes, van conectados en red, a una sala de control, a un equipamiento que puede estar conectado también con cámaras, con robots, con drones. Todo eso es lo que llamamos el mundo de los... Esta foto, perdón, me olvidé de mostrar algo por acá. Las diferencias fundamentales entre los dominios de los IT y el IT. Generalmente cuando hablamos de IT, estamos hablando que la seguridad es una de las claves del mundo de la tecnología de la información. Próximamente la integridad, significa que no haya alteración en la información que tenemos. Y por último la disponibilidad. Cuando hablamos de sistemas de OT, sistemas de redes de datos y de sistemas orientados a control de procesos en cualquier tipo de industria, puede ser generación de energía, puede ser no sé, generación de pulp y papel, alimentos y bebidas, industrias de generación de energía en distintos tipos, puede ser atómica, puede ser hidroeléctrica, puede ser renovable, biotecnología, en cualquier tipo de industria las prioridades cambian. Generalmente la prioridad está muy puesta en la disponibilidad del sistema en lugar de la seguridad. Después viene la integridad y por supuesto también la seguridad es importante, pero cuando hablamos del entorno del OT, estamos hablando fundamentalmente de que necesitamos sistemas que tengan una muy alta disponibilidad. Esta foto no fue generada con inteligencia artificial, ni mucho menos. Es más, tengo que decir que para pixelar eso tuve que usar Paint, no puedo usar ninguna otra herramienta más avanzada. Pero bueno, quizás los más grandes que están aquí podrán recordar este día, y si no sus padres seguramente recuerdan qué estaban haciendo ese día. Es un 11 de septiembre del 2001, para que tengan una referencia de cuándo fue tomada esa foto. Recuerden que está tomando mate, que era yo. Claramente no se ve allá atrás, pero había un pequeño monitor donde estábamos viendo lo que estaba pasando ese día en el mundo. Todos estaban ese día, podrán recordar lo que pasó. Y bueno, estábamos haciendo la migración de un sistema de control en una planta de explotación hidroeléctrica. Lo que se ve atrás es el viejo sistema de control, probablemente de los años 70, y estábamos instalando estas dos computadoras que eran con las que se iba a controlar el proceso de esa planta a partir de ese momento. Y el operador que estaba a la planta en ese momento tenía una computadora ahí con su correo electrónico. Hoy se habla de la convergencia OT-IT como que arrancó en el 2010 aproximadamente. El tema de Internet de las Cosas, Big Data y un montón de otros conceptos que empezamos a vislumbrar de que había cierta convergencia entre estos dos mundos del IT y el OT. Sin embargo, yo en el 2001 me di cuenta de que esto no tenía retorno. Que a partir de acá había arrancado la convergencia. El operador que estaba ahí me pidió, che, ¿no hay posibilidad de ver en las computadoras del sistema de control mi correo? Le dije, parece que no. Al final, por supuesto, eso no pasó, pero dije, esto es un camino de ida, donde se están uniendo ambas redes. Hasta ese momento los sistemas de control eran sistemas totalmente aislados. Era una computadora que controlaba un proceso conectado a una red de datos con los computadores y nada más. Ese día vislumbré que estaba la posibilidad de unir esos dos mundos y que algo mucho más grande podía pasar. Así es como luce hoy una sala de control. Son salas de control donde se integra información de la compañía con información de los sistemas de control, con cámaras de CCTV, con seguimiento de drones, de robots. Son ambientes colaborativos. Incluso esto ya es viejo hoy. Este tipo de salas de control ya prácticamente son obsoletas también. Incluso la pandemia ayudó mucho a eso. Hoy, muchos de los operadores operan desde sus casas, a través de dispositivos remotos, o directamente desde computadoras de su casa, y estos ambientes colaborativos y tan ANSI ya prácticamente están tendiendo a desaparecer. Pero así es como lucen la mayoría de las salas de control en plantas hoy en día. Pertenezco a una compañía japonesa, Yokogawa, seguramente habrán visto el stand afuera. Es una compañía de más de 100 años. Somos de los que empezamos a programar en Assembler. Y hoy, bueno, por supuesto, es una compañía que ya programa en todos los lenguajes, y ahora vamos a ir viendo un poquito más. Pero los pilares de esta compañía son la calidad, el espíritu pionero y la contribución a la sociedad. Siendo una compañía de más de 100 años, tiene estos tres pilares muy, muy adentro de su cultura. Los cuarteles centrales se encuentran en Tokio. Y bueno, acá en Argentina tenemos tres oficinas, una en Munro, otra en Rosario y otra en Santa Fe, y somos más de 80 colaboradores aquí en el país. ¿Qué hace Yokogawa? Todo lo que es útil, desde los instrumentos, ya sea para medir todas las variables primarias, presión, temperatura, nivel, caudal, distintas variables analíticas de los procesos industriales, también instrumentación de tipo inalámbrico, ya sea para Internet de las cosas industriales o directamente para procesos que son de tipo inalámbrico, todo lo que es sistemas de control y todo lo que es sistemas de gestión para la industria. Aquí es la parte aburrida que hacemos, ahora vamos a empezar la parte IA Chuya es el concepto que tiene Yokogawa para el que se viene en el mundo de la industria. Nuestra empresa en los 109 años ha sido una empresa que trabajó en automatización, control y seguridad de procesos, y estamos yendo hacia la automatización autónoma, es decir, ir hacia procesos totalmente automatizados gracias a la inteligencia artificial. Este es un modelo de madurez que usa la compañía, que muestra desde los sistemas que eran automáticos, pero probablemente totalmente manuales. Estamos hablando del inicio de la revolución industrial, donde operadores operaban en plantas, procesos que luego tenían un mix entre operadores que operan una planta y alguna máquina que podía tener cierto nivel de automatismo. Se acordarán algunos de los primeros sistemas automáticos que nacen en la revolución industrial, a procesos que son prácticamente totalmente automáticos, pero no todavía autónomos. ¿Cuál es la pequeña diferencia que hay entre un sistema automático y un sistema totalmente autónomo? El sistema automático necesita una sala de control, necesita un operador que esté operando. ¿Por qué? Porque hasta ahora cualquier cambio en el medio ambiente, diferencias de temperatura, de lluvia, vientos, o cambio quizás en la calidad del producto de entrada, o cambio en la calidad del producto de salida, o cambios en las cantidades que tengo que producir, ya sea de energía, de fármacos o de cualquier cosa que esté produciendo, necesito un operador en la sala de control que esté operando. Cuando pasamos a esta otra escala, que es de la autonomía industrial, estamos hablando de procesos e industrias que ya no necesitan de un operador en forma continua en una sala de control, sino que el proceso tiene la capacidad de operar de forma autónoma durante todo el tiempo. Incluso ya hay pruebas en Japón de plantas petroquímicas que han funcionado durante todo un año sin la necesidad de la intervención de un operador. Y ahí vamos subiendo en el modelo de madurez a sistemas semiautónomos, orquestación autónoma y operaciones totalmente autónomas. Ahora vamos a hablar un poquito más de esta última capa. Y todo esto viene dirigido o ayudado por la posibilidad que tuvimos más o menos en esta parte de la madurez de poder hacer operaciones remotas, de operar en casa, operar un yacimiento desde Buenos Aires que se encuentra en Neuquén, o en Comodoro o en Ushuaia, hasta sistemas totalmente desatendidos. De esta manera aparecen los conceptos de lo que se llama la fabricación inteligente, y de vuelta hablando de IA Chuya, desde sistemas totalmente, semiautomáticos hasta sistemas totalmente autónomos. Este es el roadmap que lleva esta transición en el modelo de madurez desde cosas manuales, semiautomáticas, automáticas, a sistemas totalmente autónomos. Pero acá lo importante es ver los enablers. ¿Cuáles son aquellos habilitadores que hacen posible que todo esto suceda? Y bueno, podemos hablar desde sensores cada vez más inteligentes, de la transformación digital, de los gemelos digitales, por supuesto de la inteligencia artificial, de los robots y los drones, de la seguridad, de todas las nuevas normativas y buenas prácticas en términos de ciberseguridad, pero hay uno acá que es muy importante que se llama OPA, Open Process Automation. Este concepto al que adhieren muchas de las empresas que hoy fabrican equipamiento para el mundo de OT, significa que el hardware ya pasa a ser prácticamente un commodity. No importa quién fabrica el hardware. Cuando hablo de hardware, hablo del instrumento, hablo del PC, hablo de las computadoras. Prácticamente cualquiera puede comprar una parte de cualquier fabricante e interactúa con cualquier otro fabricante. Eso hasta hace poco no sucedía. Cuando uno instala un sistema de control, tiene que ser el control de ese fabricante particular. Bueno, este nuevo modelo, este nuevo estándar, tiende a que el hardware pase a ser casi un commodity, y lo que realmente cambia y hace la diferencia es todo lo que está por arriba. Software, la inteligencia que yo pueda poner del proceso, y por supuesto muy guiado por la transformación digital y la inteligencia artificial. Este modelo habla de cómo, yendo desde sistemas manuales, automáticos, totalmente automáticos, totalmente autónomos, pasamos a sistemas de sistemas que trabajan en simbiosis entre sí. Eso sucede a nivel de planta, a nivel de empresa, a nivel de la cadena total de suministro y con impacto en la sociedad. ¿Qué significa esto? Imagínense una compañía que tiene varios yacimientos de petróleo en todo el país. Esa compañía tiene plantas en cada uno de esos lugares. Cada uno de esos equipos y pozos de petróleo y plantas de tratamiento de crudo funcionan en forma automática, en forma autónoma, pero después hay una refinería aguas abajo que es la que procesa el petróleo para que ustedes después puedan ir a las estaciones de carga y cargar. Cuando todo eso trabaja en simbiosis, en forma totalmente autónoma, lo que está permitiendo es que haya sistemas que charlan con sistemas y son capaces de entre sí saber cuándo hay una necesidad, por ejemplo, para producir más petróleo en la refinería y poder traer más petróleo de los campos de petróleo. Todo ese impacto de sistemas charlando con sistemas tienen parte de la sociedad. Imagínense eso en forma totalmente autónoma. Hoy todo eso es manual. Hay un señor que llama y dice, che, produzcan más el mes que viene porque hubo paro, o se llenó de vacación, todo el mundo de vacaciones y acabó combustible. Todo eso no sucede, los sistemas no charlan con nosotros. Este modelo habla de eso, de sistemas que hablan con sistemas. Bueno, para todo esto que vimos hasta ahora, Yokogawa tiene una plataforma. Le llamamos plataforma porque hasta hace poco se llamaban escadas. ¿Alguien conoce lo que es una escada? Escada es sistema de control de adquisición de datos. Así se llamaron estos sistemas de los últimos 50 años prácticamente. Son todos esos sistemas que interconectan y permiten operar una planta. Hoy ya no se llaman, o no los llamamos ya más escadas, los llamamos plataformas de operación. Yokogawa tiene su plataforma de operación con más de 44 años en desarrollo. Y bueno, está aprobado y establecido en un montón de países, y hoy se programa en Python. Es uno de los lenguajes de programación. Antiguamente se desarrollaba y se programaba en Cerezo, como comentábamos, y hoy bueno, se programa en Python y en algunos otros lenguajes de más alto nivel. ¿Qué es una plataforma de operación? Bueno, primero que permite hacer operaciones remotas de forma eficiente, entiendo, desde cada una de las plantas que uno tenga, por ejemplo, un yacimiento, una planta de tratamiento de crudo, una planta de tratamiento de gas, una operación desde una sala de control regional, por ejemplo, desde Neuquén, poder operar todos los yacimientos que una petrolera tenga en esa región, incluso desde acá, desde Buenos Aires, poder operar todos los yacimientos que esa petrolera tenga a nivel nacional. Y esto permite integrar esa operación tanto en forma vertical, el yacimiento, la región, la provincia, el país, como también en forma horizontal, poder traer información que tengo en otras operaciones dentro de la cadena de suministro que me permiten optimizar esa operación. Y bueno, por supuesto, toda la optimización de toda la cadena de valor está basada en la optimización de los datos que yo conozco en esta integración horizontal y vertical. Como hablamos al principio, en el mundo de la OT, la disponibilidad es muy importante. Estamos hablando de sistemas que tienen que estar todo el tiempo disponibles. Y para eso hay estrategias de arquitecturas distribuidas en la nube, que son redundantes y que permiten recuperarse ante desastres. Por ejemplo, el ejemplo que les daba recién de yacimiento, tenemos un cliente que tiene un sistema principal, que es el que colecta la información 4.000 o 5.000 pozos en la región, o de los instrumentos de esos pozos en una provincia, y tiene un centro de recuperación de desastres que es una copia de ese mismo centro en otro lugar, también comunicándose con los dispositivos, y posteriormente dos sistemas nube, dos proveedores distintos, en cuádruple redundancia para poder, ante cualquier contingencia, poder recuperar la operación y darle máxima disponibilidad. Se imagina que es imposible que por un problema en un sistema de datos los yacimientos paren, imposible. Entonces, por eso, la disponibilidad es la variable número uno en los sistemas de hoy. Y bueno, otra cosa importante es la multiplataforma. Son sistemas que funcionan bajo Windows o bajo Linux. Generalmente, los sistemas son redundantes, suelen ser en una plataforma de... Escucharon hace cosa de 3-4 meses, por un fallo de Windows, tuvieron sistemas de reserva parados en todo el mundo. Bueno, eso acá sería inaceptable. Creo que en las reservas también fue aceptable, pero bueno, pasó. La idea acá es, cuando tenemos multiplataforma, poder evitar esas causas comunes de problemas que pueden pasar en una misma plataforma. Entonces se da redundancia de locación, redundancia de nube y on-premise, y también redundancia de multiplataforma. Así que bueno, eso es lo que les quería contar hoy, hacia dónde va la industria en la convergencia OT-IT. Va hacia usar la inteligencia artificial para darle al mundo del OT la bondad de la autonomía. Hoy les deseo mucho éxito, sé que están todos muy nerviosos por estas 24 horas que siguen, así que les deseo lo mejor, sé que va a ser una jornada hermosa. En cada línea de código que ustedes pongan seguramente va a haber mucho talento, y bueno, como sponsor estamos muy orgullosos de poder acompañarlos en este momento y que tengan mucho éxito. La verdad que haya 81 personas acá participando es increíble, y bueno, lo mejor de lo mejor para hoy.
Buenas, ¿qué tal? Espero esté muy bien. Finalmente, nos gustaría reconocer a quienes son los verdaderos protagonistas en esta jornada. Les pido un fuerte aplauso para los compañeros. Sabemos que algunos de ustedes se estuvieron preparando arduamente con el fin de llegar bien a la competencia, y por supuesto también sabemos que las siguientes 24 horas van a ser intensas, pero también muy gratificantes. Para quienes solo vinieron por la comida, déjenme decirles que la hicieron muy bien. Felicitaciones. Pero bueno, más allá de los resultados, estamos seguros de que esta experiencia va a ayudar a seguir creciendo tanto desde un punto de vista profesional como personal. Y recuerden que esta es una excelente oportunidad para ponerse a prueba, poner a prueba sus habilidades, pero no se olviden de que estamos acá para seguir aprendiendo y aprender con cada desafío que tengan delante. Y bueno, por supuesto, disfrutar el proceso. Muchas gracias.
Bueno, vamos a hacer, como es de costumbre, una foto final, y para eso les pedimos a todos si se pueden acercar a la sección de Coffee Point. Para los que no conocen, es donde está el fondo de prensa. Sí, si no tienen la multitud.
Y después cada equipo va